Hello, everyone. In this session, we will explain the complete process of operating Metahuman from Atelier to simulator. The main points and the sequence of explanations are as follows. Let's take a look together. First, open the bridge in UE and log in. Choose the character to download in Metahuman. It's important to note that any default clothing on the character should be removed beforehand. You can click Start MHC. Here, I have already taken care of this and replaced it with a suitable hairstyle. Select Low Quality for downloading and adding. In UE, find the character blueprint and double-click to open it. Make sure to select Enable Missing for all options and restart. This way, Metahuman has been successfully imported into UE. Create a new Style 3D folder before exporting. Before exporting, you need to download the Style 3D Simulator plugin. Go to the project browser and create a plugins folder. Download the latest version of the plugin from the simulator official website. Choose the appropriate UE version within the plugin and paste it into the plugins folder. After restarting the software, a new plugin prompt will appear in the lower right corner. Select Manage Plugins and search for Style to ensure the plugin is checked. This way, you can find Style 3D at the top and log in. Note that Style 3D component is added under Body. Then, under the component, find Obstacle and add the head and feet. After adding these two, proceed to export Obstacle. In the Atelier asset library, you can download various styles of clothing. Here, filter and download suit in women. Double-click on the downloaded clothing to add it. Next, drag in the Metahuman. Make sure to change the load type to add. Keep other settings default, scale is in centimeters, and the axis is Y, up. There may be differences in body shape and posture between two avatars. If you encounter grid deformation like in the image after importing, it might be due to an outdated plugin version. It's recommended to update the plugin. Another solution is to synchronize the LODs between Metahuman and the obstacle LOD in the Style 3D component. Change the -1 here to 1, then re-export the obstacle. First, hide the clothing. Then, set Metahuman to not participate in simulation. Reduce its alpha and change its color to red for easier reference as a pose guide. You can start by changing the avatar to the existing pose to reduce the workload. Then check the avatar skeleton. After selecting any joint, a small figure will appear in the upper right corner. Check it to enable symmetrical adjustment. Then, from different perspectives, rotate the joints to match the pose. Once adjusted, click on Atelier Avatar, then Edit Avatar. In the Pose section, select Add Current to save the adjusted pose. This way, the Metahuman pose is set. Restore the pose, hide the Metahuman, and then press Shift+C to display all clothing. Now, you might encounter situations where the clothing does not match the avatar. Directly lifting the avatar will cause the feet to penetrate. This is because the previous heel height does not synchronize when switching poses. Therefore, you need to manually increase the heel height until there's no penetration. In the Color 3D tab, check Show Color 3D to view the situation of clothing patterns. Blue patterns indicate frozen areas, meaning they won't move during simulation but can affect other patterns. Except for special cases like skin-tight underwear, other patterns should be unfrozen. Green patterns mean the form is solidified. Solidify preserves the original shape, reducing deformation while still allowing stretching and other alterations. Ctrl+A to select all the patterns, check the Freeze option. Then uncheck it to ensure that all patterns are unfrozen. For the Solidify option, first check it and drag it to the maximum. This is to ensure that when changing the model, the clothing can maintain its initial state as much as possible. Next is to check the fixed pins. Finding some hidden fixed pins can be tricky and may be overlooked. Therefore, you can start by adding a few pins. Then right-click and select Delete All Pins. This ensures that all fixed pins are removed. Then, make sure to use Simulate Accurate mode, and switch the pose to the Metahuman while in simulation mode. At this point, make sure the Atelier avatar does not participate in the simulation, or simply delete the avatar. Next, display the Metahuman. Now, let's address the body size differences. Select all clothing items and click on the scale button in the upper right corner. Use the yellow guidelines to shrink the clothing and move it to the appropriate position. Due to inaccuracies in the initial pose restoration, there may be many areas where the clothing penetrates. One method is to go back to the original model and optimize the pose again. But this can be cumbersome. In reality, you only need to rotate and move the parts that are penetrating manually, ensuring that the main areas do not penetrate. For the fingers, you can stretch them while in simulation mode. After adjusting one side, simply select Apply Symmetric Meshes. For the pants legs, pull them out manually. You can also use fixed pins. First, select the areas where penetration occurs in the 3D viewport. Then further refine the selection in the 2D viewport. Choose these two areas and pull the meshes outward. Do the same on the other side. After pulling out, you can delete all the fixed pins. Now, when simulating again, there should be no more cloth penetration. Select the vest, use Ctrl+I to invert the selection, and then press Shift+Q to hide the rest of the pattern, showing only the vest. At this point, you can remove the solidification. To facilitate viewing the garment state, you can disable Textured Surface 3D. The simulation should be stable now. Next, optimize the model's vertices. You can increase the particle distance uniformly on the right side. For general pattern, it's recommended to set it between 8 to 10. While for smaller ones, between 5 to 8. For a larger pattern like a long skirt's hem, set it between 12 to 15, since there are interweaving strips in this garment and the patterns are small. To ensure stable simulation, you can decrease the particle distance to 5. Remember, the smaller the particle distance, the more vertices there are, resulting in finer simulation but also higher computational cost. Moving on to adjusting the coat. After removing the solidification, you might notice that the sleeves are too long and have too much stacking. Select the bottom edge of the sleeve. Choose Offset Pattern Outline. Select Retract, and set the distance to 3. You can first strengthen and then cancel to quickly optimize wrinkles. The shortcut is Ctrl+H. Next is the issue of double layers. To reduce the number of grids, you can choose to change it to a single layer. Press B to open Edit Sewing and see which side is sewn to the main body. Keep the side sewn to the main body and delete the other side. The same goes for the cuffs. Then change the render thickness of these double layer structures to 2, which is double. Press 2 and then enter. This can reduce the number of grids while ensuring the thickness of the double layer. Finally, for the trousers, pay attention to the unsewn parts. The inner side of the fake pocket is not sewn. There is a risk of revealing the filling when moving, so you can delete the inside of the pocket. Press D for the pen tool. Hold down Ctrl to draw curves. And right-click to cut. Press M to sew the outer side of the pocket to the trousers. Note to remove the seam lines from the normal map. Then set the render thickness of the pocket to 0. This creates a thickness difference, giving the impression that the pocket is underneath. Also, the trouser cuffs need to be sewn. The particle distance here appears in red, indicating differences among different parts of the trousers. You can use Simplify Meshes in the tools. Change the particle scale to 2 and the max particle distance to 15. Then check Simplify Selected Only. This allows the patterns to be simplified according to their original particle distance, enlarged by a factor of 2. In cases of penetration, set the layers of small parts on the trousers to 1. Check if the buttons are selected for collision, and also ensure they are not frozen by right-clicking. After adjustments, select all the clothing, and you can see the total number of vertex counts in the bottom right corner. For live scenes, recommend the clothing within 50,000 vertices, while for production scenes, it can range from 80,000 to 200,000 vertices. Finally, adjust the UVs. After modifications, the UVs may change, so it's necessary to double-check. Open the UV editor, which supports multi-quadrant layouts. Therefore, you can select the patterns under the same material, then click the Arrange button in the upper left corner to automatically lay out. Select the Move button, change the distance to 1, and then move them one by one. Check Arrange 3D Trim under the Settings button to arrange the UVs of the buttons. After setting this up, you can export the SMD. Here check Bake All Maps. Then confirm. Create a new cloth folder. And drag the SMD file into it. Confirm directly here. Open the asset config, check using baking texture. Double-click to inspect the clothing. Then mount the clothing on the right side. Then click Bind, Group, Save in Sequence. Add animation under Body. Select Use Animation Asset to add an animation sequence. Here, prepare an animation through redirection. If the head does not follow the body, you can use the character blueprint to combine the body and head together. Add an A-pose asset in post-fitting. The clothing is automatically fitted via skinning, but there may be instances of clipping. Click on Post-fitting. Here, the pants are still sticking together tightly, so let's check the Atelier project. Upon inspection, we found some unnecessary stitching lines on the pants that need to be removed. Re-export after deleting them. Temporarily unload the actions and clothing. Select the clothing and choose Re-import. After remounting, there may be damage as shown in the image. Unbind, then uncheck Preview in Editor. Readjust the post-fitting. This way, the pants won't stick together. Next, change Garment Simulate to Garment Cache Record. Make sure to check Record Avatar Animation, so that the character animation and clothing cache remain synchronized during playback. Uncheck Async Mode and Smooth Animation to prevent cache playback clipping. Record first to see the initial effect. Firstly, the top bounces too much. Secondly, there's a handpant sticking issue. This can be mitigated using collision filters. First, you need to unload the animation and clothing. Next, you need to draw the collision zones on the character's body. Change the mode to Mesh Paint, since the Metahuman character itself uses the RGB channels. The collision filter needs to be drawn in the alpha channel. Set the brush strength to 1. And make sure to enable all color channels for painting. On the right side, if you're using version 1.5.4 or higher, you can switch the group type to Metahuman in the collision body properties. Then, add 2 new indexes under collision group and name them left arm 1 and right arm 1. Set the colors to 0, 1, 0, 0.6 and 0, 1, 0, 0.8 respectively. Follow the color codes provided in the image to paint the limbs. Ensuring to check from multiple angles and adjusting the brush size for precise painting. Once done, click Save. First, mount the clothing. Uncheck Enable Pose Fitting. Then unbind. Make sure not to mount any animations yet. With the character in the default pose, click Bind, Group, and save one by one. This will automatically set up the collision filter for the clothing. Double-click the clothing for inspection. Click on the pants pieces. Then in the cloth pieces sim property, locate the collision group. Cloth represents the clothing, specifying that the pattern belonged to the left leg garment. The collision mask should be set to not collide with the right pant leg clothing. Right leg. Left and right arms. This means the left pant leg should not collide with the arms. It can solve the previous issue of the hand sticking to the pants. Next, for the 2 newly added arm masks, they can also be deselected. The remaining patterns can be modified based on the actions. For the excessive bounce in the top, you can adjust the fabric's physical properties. Then, locate the physical properties panel. If the fabric is too bouncy, you can decrease the stretch value. Remember to save after making changes. Lastly, adjust the solver properties. Increasing the iteration count can make the solver results more accurate. Let's preview the recording. Both issues have been significantly optimized. First, copy the cache name, then change the mode to Garment Cache Play. And paste it into Cache to Play. If there are no issues in the preview, you can add the cache track. Right-click to create a new level sequence. First, add the actor track and find the character blueprint. You can delete the 2 control rigs. Then, under the character blueprint track, add a subtrack for Style 3D, add the garment cache to the Style 3D track. And a recorded animation is added. Add an animation sequence under the body. This way, our cached animation is added. Then add the camera. Adjust the camera distance and focal length appropriately. Use the debug focus plane to determine the center position of the action. Finally, play to see the final result. If there are no issues, you can render the output. The full process of Metahuman operation is now complete. Feel free to like and share the video, and participate in the comments section. See you in the next video.